Dr. Reichert sends her regrets. She was unable to join us. She's on leave, so I'm filling in for her today. And in the Vaccines and Therapeutics division for biological threat agents, we tackle a number of interesting problems, and boy, those lights are bright. You don't always know where to start. So when I first got in the division, I went into Dr. Hand's office and I said, "Sir, I think it'd be really nice if we sort of thought about a long-term, vision. What are we going for?" And so I said, "Well, I have in mind, the cart that Cuba Gooding got into in Outbreak. He goes in with a bag of blood, and 5 minutes later he comes out with the vaccine. I want that cart. Can we make that?" And Dr. Hand looked at me and said, "That's interesting, but no, I want better than that." And he said, "I want to have a warfighter with a device on this arm, and it senses what it's being exposed to, and on this arm, it automatically injects the countermeasure." So I was outdone. But the concept of forward deployable real-time medical countermeasures is something that we have in mind. It's a long-term vision, and if you walk back to where we are today, we're trying to plot that path, and I would encourage you to think about what is that road that gets us to that long-term vision, which would counter the sort of threat environment that Dr. Hand raised during his talk elegantly. So if we go to the next slide. Oh, I can do it. I think I can. So we talk about vaccines because at DTRA, apparently the word prophylaxis is not allowed to be put on doors. I'm not sure what the confusion is, but I want you to think about vaccines in the context of prophylaxis. So we're not just interested in vaccines. If you have a technology that would prevent an infectious disease, whether it might be some immune modulator, a monoclonal antibody, a aptamer, they all fit into this basket. And as you know, we have a number of threat agents. I'm not going to list those out for you, but these are the ones that the services have put as their priorities for now. It doesn't mean that we're completely restricted to that list. There are other ones that might be of interest, and certainly if you run into SCMs, don't limit your conversations to just this list. What is more important is the approaches, and as we sort of move towards this modern vision, we are very interested in platform-type technologies. Now, to define a platform is complicated, but I would just say that it is something that brings an efficiency to the process of going from discovery to delivering a countermeasure to a warfighter. By efficiency, that means that it's a low-risk exercise. A lot of the problems have been solved. So a good example would be a DNA vaccine. You have a system where you plug in a gene that produces the target gene product, and then one can manufacture using a known manufacturing process. There's nothing new that has to be developed. It can be done in very quick timelines. And so if a surprise occurs, an answer can be developed in a response to a real-time crisis within a meaningful time, allowing us to defeat that threat. So, so that's sort of part of the approach, and I think that we're not only locked into that. I come from the old school, and there's nothing wrong with just growing up things, killing them, and putting them in alum or old adjuvants. That works too. So it really just gets down to how do you put that into a platform? How do you make that a meaningful process that can be delivered in a very quick time? In terms of, I just focus a little bit on the bacterial threats, and we'll come back to that with the antibiotics as well. It gets a little bit more complicated when you have a big genome that sort of is plastic, like the Burkholderia species, allowing them to have many, many different genomes that parts are a core part of their surface, and the opportunities for targets are very different bug to bug to bug. And so, pulling out one target and making a solution that way may not be feasible. And so I think if there's a space where your creative minds want to spin the wheel, that's the space that we're very interested in, finding platform approaches to solve these more complicated organisms. So if I go to the next slide. So to tie that together, the enabling sciences, and I've already touched on this a little bit, but it gets deeper than that. We have animal models, but can we escape the animal models? Dr. Hand's been a champion of the ex vivo, human on a chip. I like these technologies, but we still don't know how to use them. And so we need to move those technologies now into IND-enabling studies so that the FDA can see them and see them side by side with traditional approaches, and therefore understand what does this technology bring to the table that the other one brought, and what doesn't it bring, or does it bring more? And can we get rid of the animals and therefore go faster, reduce our costs, and certainly reduce the animal use burden? I think these things are feasible. It will take time, but we have to commit to it. So as you think about your planning, certainly think about including these things and other types of single-use applications, disposable applications, to accelerate that timeline. Because really, this is one of the biggest time consumers. Making an assay to tell you that your countermeasure works can take years. And we haven't solved that problem yet. So we need to solve that problem. All right, in the therapeutics area, it's a similar list on the one side on the left of targets. And, the filoviruses are of particular interest because we saw what happens when a virus like that can explode all of a sudden as it does in a sporadic epidemic. I keep slipping into my Australian accent there, and that's probably why you're losing me a little bit. But so anyway, I think that what we learned from that was that we really weren't ready to deploy opportunities to the field. And so JPO is working on that, and I think if you can seek them out and learn a little bit about the JMedic program, it would be very good for the developers and the discoverers to know about that and know how to connect to that if there is another epidemic, because they're setting up a portable mobile field unit that can do controlled field trials in the case of a new epidemic. And that's very important because a lot of the data that were generated during the last epidemic were more or less useless. And so that's a shame, really, because I think there were a lot of encouraging leads that we had. Encephalitis viruses, again, the big hurdle there for conceptualizing where the limitations are in technology is the blood-brain barrier. How do you get things safely across the blood-brain barrier? How do you defeat drugs, infectious agents that have already made it to the brain? Those are the problems there. It's not that there are no solutions, but with every solution that's out there, there are risks. And if you have a relatively mild virus, you don't really want a high-risk solution to come and treat a relatively mild virus. So there's room for improvement there. The biotoxins, there's not much time there, and the place where we're encouraging thought, and certainly, you have to contact us if you have things in this domain where you have ideas of tissue regeneration, because really, once the toxin has sort of catalyzed the changes to the cell, there's not much you can do other than turn on genes and rebuild what the toxins destroyed. So if you have thoughts in that domain, and not just restricted to botulinum toxins, other biological toxins, restorative medicines are certainly a category, an idea that we're very interested in. And then, of course, we get to the bacteria, and I'll just repeat my comments there, which is that this is one of the places where genetic engineering could have a lot of fun, and actually create a lot of misery, unfortunately. Yeah. So, I think what I often see with this, and I'm still confused by it, maybe someone can help me understand it, but during the HIV epidemic, I mean, David Ho put 3 drugs together because it was clear that a single drug developed antibiotic resistance, and people became refractory to treatment, and the virus took off again and they died. The solution was multi-drugs. We now have several of these cocktails that keep HIV at bay for decades in an individual, to the point where we're now considering using this to eradicate the virus from the planet. Why don't we have that for bacteria? It's staggering to me that we still use a single antibiotic, and then we get surprised that these organisms that mutate at incredible rates, and even faster when they're under stress, develop antibiotic resistance. Why is that a surprise? And why don't we have these multiple approaches? And if you have a multiple approach, can they synergize so that even if a bug has an antibiotic resistance to one drug, can you quench that resistance with another drug? So I think there's so much room for creative thinking there that I would encourage folks to put their ideas down and come in and give presentations on how they would tackle that area. You go to the next slide. Oh, that's me. Yeah, I'm just a fill-in. Anyway, and of course there are the enabling sciences. Delivery methods, how do we make this simpler? Can we have antibiotics, for example, on patches? What makes it easy for the medic? If he runs up to the field and he hands out, packages of pills and take one every day, these kids, they're going to forget 2 days in because they feel better. And that can make the problem worse. Can we just slap a patch on and they're treated? The medic can tick the box and move on and not worry about compliance. And then, of course, novel target identification. I mean, this is an area that is very challenging. Big industry has not sort of pushed back the frontiers on this area, and it's up to us. In fact, I think the people sitting in the room probably do hold the key to making antibiotic era go for another 100 years, or it ending, and we go back to an era where we're all afraid to shake each other's hands. And that is a very serious threat. That's a real threat. And so I hope that we do together develop ideas for that next generation of antibiotics and keep that as a solution for the medics and the doctors in the field. If we go to the next slide. Oh, me, mental note to me. It's not working now. There are no more slides, good. So I'm done.